In this video, I'll give you some tips for solving the ALEKS problem called predicting the relative boiling points of pure substances. This problem is actually pretty tricky. Hopefully I'm going to give you some pointers to help you get it right on the first try. So for this problem, you have 4 different substances and you're being asked to rank them according to their relative boiling points. The first thing that I want you to do is look through your 4 compounds and find anything that is a metal atom. So if maybe you're going to have a metal atom, just a single metal atom all by itself. Or you might have an ionic compound. If you do have a metal atom or an ionic compound, that is going to be your highest boiling point substance. I flipped through a lot of different versions of this problem, and every problem that I saw either had 0 metal atoms or ionic compounds, like mine. I don't have any metals here at all. Or it had just 1, all right? So it had 1 metal atom or it had 1 ionic compound. I didn't see any version of the problem that had 2 metal atoms or had 2 ionic compounds, or it had a metal atom with an ionic compound. So I really don't think that you're going to run into that situation. Hopefully you don't. If you do have a metal atom, it is going to be your number 1. Once you've got that metal atom sorted out, or maybe you don't have one, like I don't have one, the next thing that I want you to do is find the molecular weight of all of the other substances that you have, everything that you haven't ranked yet. And so if you do have a metal, just take that out of the consideration. It's your number 1. Don't think about it anymore. Find the molecular weight or the molar mass of everything else. And I have already added mine up and I've got them written here just for reference. So find the molecular weight of everything that you have left. And you should notice some sort of trend or pattern in the molecular weights of these compounds. So you can see that I have 2 compounds that have molecular weights that are pretty similar to each other in the 60s. And then I have another 2 compounds that have molecular weights, again, pretty similar in the mid to upper 30s. So find your molecular weights and then also find the trends in or patterns in those molecular weights and group the compounds that have similar molecular weights. So find trends and group compounds with the similar molecular weight. I'm just going to call it MW. So these 2 compounds right here, similar molecular weight for me, and these 2 compounds right here, similar molecular weight. Now, the heavier compounds, the ones that are heavier in general, are going to have higher boiling points than the ones that are lighter. So for me, these 2 compounds down here, because they have lower molecular weights, these 2 compounds down here are going to have lower boiling points. And these 2 compounds, because they have higher molecular weights, these are going to be the ones that have my higher boiling points. So one of these is going to be my number 1 highest boiling point, and the other one is going to be my number 2. And then these ones, one of them is going to be my lowest, number 4, and the second lowest, number 3. Now, the way that we're going to distinguish these from each other, so the way that I'm going to decide of these 2, which one is the highest, is by evaluating their intermolecular forces. So as I'm comparing these 2 to each other, I'm going to make a note here, compare the intermolecular forces of compounds with similar molecular weights. Compounds with similar. So we're not just looking for the strongest IMFs in general. So I'm not comparing the intermolecular forces of all 4 compounds. I'm looking for the strongest intermolecular forces between these 2 compounds. And in terms of intermolecular force strength, the hydrogen bond is the strongest. And if you have hydrogen bonding, that is going to be your strongest IMF. And so if I'm looking at these 2 compounds, just these 2 compounds, I can see that I have intermolecular forces, hydrogen bonding capability right here. This molecule doesn't have any hydrogen bonding capability. So this is going to be my molecule that has the highest boiling point, number 1. And again, the reason for that is because it is in the group of molecules that has the highest molecular weight. And within that group, it's the molecule that has the strongest intermolecular forces. This is going to be my second highest boiling point. It's in the group of molecules that has the highest molecular weight. Now I'm going to come down here and I'm going to do the same thing. I'm going to rank these because these are the lighter molecules. These are going to be the ones that have the lowest boiling point. And again, to distinguish between the 2 of them, I'm going to compare their intermolecular forces. Now, neither one of these molecules is capable of hydrogen bonding, So I'm not going to be able to use that. My second strongest intermolecular forces are the dipole forces. And then my weakest is the dispersion force. And the dispersion force, which is the weakest force, this is a force that exists between molecules that are nonpolar. Nonpolar molecules are molecules that are totally symmetrical. So if I'm looking at this molecule right here, when I'm looking at this molecule, it is not completely symmetrical. It's got this asymmetry associated with that carbon-fluorine bond. This is a completely symmetrical, just a little F2 molecule. So this is going to be the one that has the lowest boiling point out of all of them, and this is going to be my number 3. Now, I'm not spending a lot of time helping you going over the process of determining which intermolecular forces are present in sets of molecules, because I'm assuming that you already know how to do that. So I'm assuming that you already know how to look at these molecules and determine whether or not they have hydrogen bonding or dipolar dispersion forces. If you don't know how to do that, I have a lot of videos that talk about how to distinguish or identify intermolecular forces. And so I recommend that you go back and find some videos that cover that topic that I will go into. In those videos, I do go into a lot more detail on how to identify intermolecular forces, and that will help you solve this problem.